All right, welcome to Lab 4. So again, I'm going to walk you through where to get everything, materials, all that fun stuff. This one definitely requires a lot of the little chemical bottles in your kit, so we're going to make sure that you want to take the time to make sure you find the correct ones. But let's start with getting the materials. So Unit 4 lab, this is another discussion lab. There's one question that I'm going to emphasize that you try really hard on and utilize that question to come up with ways to communicate and discuss with your classmates. But we'll get there. So first off, you can go to 4.07, that's where the actual lab is. 4.08 is where you'll turn into the discussion and the proof of your hands-on lab. But you can also get there from this course plan. This is actually something that will be in February, I believe. Yep, and a bump ahead a month. So 4.07, 4.02, 4.05, or sorry, 4.05, no. 6. Yeah, 4.07 was what I was looking for. Sorry about that. And more. So, lesson introduction does have student guide, which will give you couple of questions to help you take notes through this laboratory results part. This is where the recording will be. Investigation does contain the virtual lab, and just a heads up on this one, all of the chemicals that you need do come in your kit. So there should be no reason why you need to do this. Everything is in your kit for this lab, so there should be no reason why you need to do the virtual one. This virtual lab also, unless they made changes since the first time I taught Chemistry A, actually has lots of mistakes. Okay? So, with that in mind, do this one by hand. Make sure you send me those pictures or video, or with this one, if you did a really detailed data table, that would be sufficient for getting your credit. Okay? Ah, my goggles broke. So if something like that happens to you, try to find another pair. I'm not able to do that at the moment, so I'm going to see if I can fix them. Sorry for the delay here. You can slowly fast forward until you see the continuation of this. Sorry, I can't actually pause it. So let's see. This work? It's released. Alright, while I do not advise it, I am going to do this without goggles on. But, alright, so 4.07 has the lab itself. 4.08 is where the discussion is, and that's actually where we need to go. So I'm just going to open this one up so we can move forward and get there. 4.08, again, this lesson introduction and learn salts is, I believe, the exact same thing as from the one before. But the discussion here, this is where we're going to get our LRD, our lab report document, and the questions we need to answer. And then proof of the hands-on lab goes down here. But the discussions, the actual lab assignment, here we got the rubric and 4.07. That rubric is not exactly up to date, just so you know. I don't mean, oh, we're broken. Alright, so LRD. And I just want to confirm, usually these are the exact same questions you have to answer. Yes. All right, so the LRD questions are the exact same questions as the ones here. All right. So we'll come back to these, but it's this question 3 that I want you to really focus on when it comes to the discussion. 1 and 2, you're going to have to do, and you're going to have to do correctly. But 3 is the one that I think is going to create the thought-provoking discussion I really want to see in here. All right, so there's what you need as far as the actual lab goes. Then, actual hands-on equipment, you're going to want your laboratory guide. Lab starts on page 13, 12, 13, 13. Okay, materials list is on page 14. Again, you should be wearing your safety goggles. Mine just broke, so I'm going to just be really, really careful. But it's not advised to do this without those. You're going to want a well plate, toothpicks or a stirring rod. If you go the stirring rod route, you're going to have to wash that off after each time you stir. That way you don't cause any false positives because you're carrying chemicals from one well to the next. Which is why I'm also going to grab some paper towels. And then the big long list of chemicals. We need tons for this one. Alright. So I think I actually, so small bottles, you're going to need barium nitrate 0.1 molar. Aluminum chloride 0.1 molar. Potassium chloride 0.1 molar. Sodium hydroxide 0.2, and that's actually a typo. That should be an M, but it says N on mine, so it might say that on yours. Magnesium sulfate 0.1 molar. Sodium chromate 0.2 molar. That has a yellow hue to it, as does potassium chromate 0.2 molar. And last but not least, silver nitrate 0.2 molar. Silver nitrate is in a solid bottle instead of a transparent one. And that's because light will actually cause the silver in the silver nitrate to come out of solution. So we have to protect it from light. Then, slightly larger bottles, you're going to need 0.1 molar aluminum sulfate, 0.1 molar magnesium chloride, 0.1 molar sodium sulfate, 0.1 molar barium chloride, and 0.1 molar magnesium nitrate. Okay? So take you a second to find all of those. Make sure they match what they say and have the appropriate sizes and things like that. All right? There's a few bottles that say they have a phenolphthalein indicator in there. That's for a different lab. You don't want to accidentally grab one of those for this lab. Okay? Now, all right, so what you're doing, the material says just one microplate, right? And based on this lab, you're doing 45 different chemical combinations here, all right? So based on this lab, you're going to be using the well plate, rinsing it out, using it again. So if you want to use both, go for it. All right, another thing you want to have handy is your hand lens. All right, that way you can take a closer look at things if you're not sure a reaction's happening. But let's look at the lab guide. All right. I definitely suggest having a table like this set up, and I'm going to say do this in pencil because I'm not sure if they need these back from you. Maybe in very light pencil, you can put a marking of like a P and a C, C for color change, P for precipitate, if that occurs by the little table here. All right, because you got a lot of reactions going on. There's no way you're going to sit there and memorize and remember which ones do what. Right? You need to record it somewhere. All right, so either set up a table like this one with all reactions from set 1, set 2, and set 3, or very lightly in pencil, and you're going to go back and erase it later. Make some sort of marking in the book here so that you know which ones reacted and which ones didn't, right? And then you just got to follow along, all right, and start combining your chemicals. Now, it says on the next page, procedure. Place 10 drops of barium nitrate into well 1A of the 24-well microplate. Place 10 drops of sodium sulfate. So every single time it's going to be 10 drops of each chemical. You're going to combine them together. You're going to stir it. And then you're going to rinse off your stirring rod or throw away your toothpick and make note of any color changes and any precipitates that form. Okay? So the key is we're really looking for precipitates here. Possible you may run into some gases being formed, and if you do, make note of that as well. But we're really looking for precipitates here, because that's where we're gonna get good things going on for that question 3. All right. So what I'm gonna do is I'm gonna combine things until we get a reaction, and then I'm gonna explain what to do when you do get reactions. So the very first one, barium nitrate and sodium sulfate. So double check and make sure barium nitrate, right? At this point, you should be able to look at BaNO3 and say that it's barium nitrate, all right? Otherwise, if you're not sure, you're gonna have to look all these up. And sodium sulfate. That's one of my big ones, right? So in A1, so that I'm actually matching what the book says and I don't forget. Again, this is why I wear gloves, because it's actually spilling all over the place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of the barium nitrate. Put my cap back on. Put that back. And sodium sulfate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So we have a reaction. 2 clear liquids making something milky white. That's a reaction taking place. All right. So if you want to confirm, you can stir it, but since I have to clean off my stirring rod, I'm not going to. But what you're going to do with this, so you're going to keep going. You're going to do all of your reactions, but I'm going to make note that it turned white and formed a precipitate in A, 1A for set 1. When you get to the end, the questions you have to answer. All right, it says, list at least 2 chemical reactions that resulted in a yellow, orange, or red precipitate. So that's going to happen. Keep an eye out for those. For these reactions, list the possible chemical name of its precipitate. What do these reactions and the others with similar color reactions have in common? All right. So again, you're going to want to do this probably for everything that you have a reaction for, not just 2, because you need to find what they have in common with each other. You only have to show me for 2. All right. Then you do the same thing in question 2. List at least 2 chemical reactions that resulted in a white precipitate. For these reactions, list the possible chemical name of the precipitate. What do these reactions and the others with white precipitates have in common? All right, so I'm going to do this first one for you. Show you what you need to be doing here. That's why I have this piece of paper. And where did the pen go? All right, so that very first reaction was barium nitrate and sodium sulfate. All right, so for this one, we've talked about this in classes before, so you may need to go to a recording to get this list. But these guys, these are polyatomic ions. So you want to look for a recording on polyatomic ions. All right. Polyatomic ions have known charges. All right. NO3 always has a -1 charge. SO4 always has a 2 minus charge, right? And then you have your metals up front. Most of the metals in here, not all of them. Let's see, I'm trying to think. Maybe all of them. With anything with iron. Alright, so for this lab, because we have nothing with iron, every single metal in here comes from your group A ions. Alright, so that's going to be the left side of the periodic table. You got 1A, 2A, and then we're skipping the transition metals. And then we have 1, 2, 3, 4, 5, 6, 7, 3A, 4A, 5A, 6A, 7A. I have way too many lines here. 8A, and then I don't need these. All right, if you remember, we've talked about this several times now. These A groups form the number of valence electrons as the number. So 1A has 1 valence electron, 2A has 2 valence electrons, 3A has 3 valence electrons, right? And this forms a pattern when they form ions. When you have very few valence electrons, you give them away and form a positive ion. So group 1A makes a +1 ion. Group 2A makes a +2 ion. Group 3A makes a +3 ion. 4 is where everything changes. Now understand you're not going to see anything from 4 in this lab. Right? But after 4, when we have 5A, we want to get to 8 electrons, so we're going to pick up 3, making a -3 ion. 6A makes a -2 ion, and 7A picks up 1 electron to reach 8 to make a -1 ion. Right? Barium falls in 2A. Sodium falls in 1A. Right? So we have Na plus and Ba2 plus. This is what you have to keep in mind when you do your double displacement reaction. Every one of these is going to be a double displacement reaction. That basic formula, AB plus CD, your positive ions switch spots. So you're going to have CB plus AD. Now, when they form, right,